Thanks for joining me today. Say, have you ever thought about water? I think it'd be fun for us to think about water. You know that water is mentioned over 700 times in the Bible? Yeah, it really is. Now, let's take a look at some of those instances. And in John 4 7, this is the story of the history where Jesus met the woman at the well. And it says, a woman of Samaria came to draw water. Jesus said to her, give me a drink, for his disciples had gone away into the city to buy some food. Then the woman of Samaria said to him, how is it that you, being a Jew, ask to drink from me, a Samaritan woman? For Jews have no dealings with Samaritans. Jesus answered and said to her, if you knew the gift of God and who it is who says to you, give me a drink, you would have asked him, and he would have given you living water. That's very interesting, living water. What he was saying to the woman was that he could give her eternal life. That's amazing. Hey, well, let's go ahead and do some water experiments because there's a lot of things in the Bible that talk about water. And hey, I'm ready to go. I got my life jacket on, but let's take a look. First of all, who created the water? Jesus created the water. I've got a little globe right here, and on the globe we usually see some blue areas. All of those blue areas are water, and in fact, water makes up about 3/4 of the whole area of our globe, of planet Earth. We've got to have water. Every life form that we know of has to have water. And Jesus wants to be the water of life for you and me. He wants to give us eternal life. And all we have to do is just accept it. Well, I'm going to move the earth over here. Okay, let's get that out of our way. And have you ever tried to float? Well, it's easy to float if you got a life preserver on like this, although this one's a little small for me, okay? And so I think what I'm going to do, I'm going to take this one off, okay, since I don't have to float right now. But how do you float? How many of you can float? Can you float in a swimming pool or maybe in the lake or maybe in the ocean? Well, some people can't float and some people are floaters. Well, let's try to figure out what is this thing about floating? Well, let's see. I've got some water right here. Let me get this water pan over here. There we go. And I have a boat. Now, boats float on the water, don't they? Yeah, they do. They float on the water. And this little boat right here that I made out of a milk carton or a juice carton made out of cardboard, it floats on the water. Now, how can it float on the water? Well, the water has what we call, it has buoyancy, and we're gonna try to figure out exactly what that means. Okay. Now, if I put too much weight in the boat, then the boat would do what? The boat will probably sink. And so what I'm going to do here is I'm going to take this little boat, let me take it out of the water, and I'm going to let's do our experiment, okay? A boat will float because it displaces less water than it weighs. And so we're going to make a little mess right here. So here we go. I'm going to put this little tray right here to catch the water because we're going to try to displace some water in my water bowl right here. But first of all, what we have to do is we've got to fill this bowl up to the very, very top, okay, of water, okay, to the very, very top. Okay, that looks pretty good. Let's see if my boat will float. So I'm going to put my boat right in there. Yep, and the boat floats without spilling water over the edge of the bowl, okay? But what I want to do is I want to fill that up so that it's just at the edge, and so the water's just about ready, okay, to spill over. All right, just about ready to spill over. So let's put it a little more. Okay, right about there. That's an awful lot of water, isn't it? Now, what would happen if we put too much weight in the boat? Well, some of that water in the bowl is just going to run over the edge of my bowl. And so I'm gonna put some weight in the boat. And let's see what we got right here. I've got some polished rocks, and this is pretty good. My cousin in Colorado polishes these rocks, and he gave me some. So let's see what I got. So I'm gonna put a heavy stone right there. Okay, there you go. I'm gonna put another one in the front. okay, and that kind of balances my little boat out. But we're still not doing what? We're still not getting some water dripping over the edge of my little bowl right here. So I'm going to put some more of these stones right here. Let's see what I got right here. I'm going to go ahead and put some smaller ones. There you go. And there's some smaller ones, and there's some bigger ones. So we're going to try to space out. Whoa, what happened? Can you see that? Some water is spilling over the edge. It's spilling over the edge of my bowl. Now that's interesting. But my boat is still floating. My boat is still floating. Hey, do you remember that history lesson about Jonah? You know, Jonah was running away from God, wasn't he? And he hopped on a ship and he tried to get as far away as he could. And there was a big storm. You remember that? And the big storm, and the sailors thought that they were going to drown. But what did they started to do? They started to throw the cargo over. They started to throw what the ship was bringing to another port. They tried to lighten the ship, and that's what happened. They tried to lighten the ship, but still it wasn't light enough, and they thought that they were going to drown. And finally, Jonah said, if you want to save yourselves, just throw me overboard. And that's what they did. So what do we do? Well, I've got some water right here, and that water, it just went right over the edge. Let's see. I'm going to go ahead and we're going to put some more rocks in my boat right here. We'll get some more weight in my boat, and more water is spilling over the edge. More water is spilling over the edge, and we're going to collect that water, and we're going to weigh that water here in just a little bit. So look at that. Look at all that weight, all those rocks in my little boat, and my boat is still floating. But pretty soon, oh, look at there. Oh, my, look at that. It's going to sink. If I put any more weight in there, it's going to sink. So right now, the boat is what we call, it's buoyant, okay? And the water is holding the boat up. And we still got some water dripping over here, okay? And what I'm going to do is I'm going to wait for that to stop, and then I'm going to take the boat out, and we're going to weigh the water that spilled over the edge of my bowl, okay? So, oh, there it goes, and we just got it drop. We got a few drops right here. All right, I'm going to go ahead. I'm going to lift my boat right out of the water. Boy, that's heavy. That boat is heavy. It has a lot of weight right now. I'm going to put that over here, all right? Let's see. I don't want to make a mess, but I'm going to have to put this on the floor or put it over here. Let's get it out of the way. All right, see if I can do that without spilling any water. Oh, there we go. Okay, now that's interesting. Now, what I have right here is I've got a little scale. I'm going to go ahead and weigh the water that spilled over the bowl, over the edge of the bowl. That's what I'm going to do. Okay, and so let's go ahead and weigh that, and I'm going to weigh that water by putting it in a little cup. All right, so let's go ahead. Let's see if we can put all of that in a little cup right here. So let's see, make a little bit of room on my table. All right, let's see what we've got right here. And I'm going to see if I can't pour this water in my little cup right here. Now, that's going to be kind of tricky, isn't it? So let's try to pour that in there. And we got some water in there. Got some water in there. Whoa, look at that. Whoa, now that's a lot of water in there, isn't it? And then what I'm going to do is I'm going to go ahead and I'm going to weigh that water. I'm going to weigh that water. Let's see what that whole thing weighs, okay? And I'm going to weigh this. Let's see what we got. Okay, that weighs 110 grams. That's how much that water weighs, 110 grams. I'm going to pour that out right here because we still have some more water that we displaced from my big bowl. And let's go ahead and pour that in here. So we have 110 grams plus, let's see what else right here. Let's go ahead and we'll drop that in here. So we had 110. And this is 60, 110 and 60, that's 170 grams of water that weighed, 170 grams. Now what we're going to do is we're going to weigh the boat with all of the cargo in it, all those rocks in here. So let's see how much that weighs. Let's see how much that weighs. Whoa, that's interesting. And that weighs, wow, that weighs less than the amount of water that we displace. Now that's interesting to me. And that means that that boat can float. That boat can float. I think that's very interesting. So something will float if it displaces more water than it weighs, the thing that's floating. Now we're going to do some more experiments with water. Okay, let's have some fun doing some water experiments. You know, we've got to have water. You know, if you don't have enough water, we'll become dehydrated. You think you can live longer without food or longer without water? Well, we can live longer without food than without water. We've got to have water. Well, I've got a tank of water right here. This holds about 3.5 gallons of water. I've got some items. We're going to try to see if some of these items will float or if they will sink. Let's see if you can guess and see if you can get them all right. First of all, I've got a, let's see, what do we have? Oh, I got a rock. Do rocks float or do rocks sink? Put it right here, let it down. Well, it sinks. So rocks sink, right? Well, maybe not every rock. I've got a special rock right here. Let's check this rock out. Now this rock here is volcanic rock. It's volcanic rock. And I'm going to put this in the water. You think it'll float or you think it'll sink? Put it in the water, let it go, and it floats. Now, how come that rock floats and the other one, it sunk down to the bottom? Well, volcanic rocks have little air chambers inside of them. And the air chambers is what helps the rock to float. But you know, if we leave that rock in the water for a long period of time, then those little air chambers are going to fill up with water and it will most likely sink. So let me take that out. Okay, there you go. And it gets heavier and heavier as it absorbs more water. It's kind of like a sponge, kind of like a sponge. I've got some more things right here that might float or sink. This is a 1 pound little dumbbell weight, okay? Think it'll float or sink? Put it in the water and it goes down to the bottom too. It won't float. It's way too heavy. So let's see what else we've got right here. I happen to have a ball. This ball is made out of styrofoam. And you know, styrofoam has a lot of holes in it, doesn't it? You think it'll float or sink? Put it on the water. It floats very nicely. Floats way at the top of the water. Okay, so a styrofoam ball like this will float. Okay, let's see. I've got another ball. Let's see, check this one out. This one is made out of solid steel and it weighs about 50 grams. And if I put it on the water, you think it's going to float or you think it'll sink? Whoa, and it sinks down to the bottom. It definitely doesn't float at all. But you know, I've got another steel ball right here. Here's another steel ball. Now this steel ball, it weighs the same as the steel ball that sunk. They weigh both 50 grams. You think this one will float or not? Put it on the water, and it does. It floats. It floats very nicely. Well, how come it floats? Well, it weighs the same as the one that sunk, but this one floats because what's inside? Air. There's air inside, and so it floats. That's interesting. So air is important to things that float. Hey, I've got some, what are these right here? This is a piece of citrus fruit. Will it float or sink? Let's check it out. Whoa, I thought it was going to sink, but it's floating, isn't it? It's floating at the surface. Let's see what we can do with this one right here. Have you ever peeled citrus fruit? Peeled all the peeling off? That's what we're going to do. We're going to try to peel the peeling off, and then we're going to see if it will float without the peel, okay? So let's see what we can come up with right here. See if I can get all this peel off in one piece. All right, here we go. Hang on, there we go. Okay, almost done, almost done. All right, now I'm going to drop it in the water to see if it'll float or will sink. What do you think? And it goes, it sunk. Before it floated when it had the peeling on. So what about the peel? What do you think the peel does to that piece of citrus fruit? What do you think it does? Well, the peeling floats. The peeling floats all by itself. And why does it float? Well, it floats because the peel has a lot of air chambers in the peel. A lot of air chambers in the peel, and so it helps the citrus fruit in order to float. I can float another one. This one here has the peel on it, and it floats. Now that's interesting. Now you may want to check out some different fruits and vegetables that you have around the house and see if you can guess if they'll float or they'll sink. But if you take the peeling off of some of them, then you might find out that those that floated pretty well when they had their skin on or the peel on, they may not float after you peel it. That's very interesting. Now I'm going to go ahead and I'm going to remove my citrus fruit right here. I've got some other items. Let's see what we can come up with right here. I have a piece of wood. Does wood float or does wood sink? There's a piece of wood. Well, that floats nicely, doesn't it? I have another piece of wood right here. This is a little piece of wood. It's a slab, okay? I'm going to put it in my water. Oh, it floats very, very well. And we have boats that are made out of wood, don't they? Yeah, yes, we do. We have boats that are made out of wood. And so wood floats, okay? Or does all woods float? Let's check this out. I've got a piece of wood right here, and it's just a rectangular piece of wood. You think it'll float or will it sink? I put it in my water, and it sinks down into the bottom. It didn't float at all. I've got another piece. It's made out of the same kind of wood. This wood is called ironwood. They call it ironwood because it's very, very hard. What makes it hard is it's very, very dense, and it doesn't have a lot of air sacs or air cells in the wood. And so when you put it in the water, it just sinks to the bottom. Now I've got another piece of wood right here. This is called petrified wood. It's real wood, but you think it'll float or you think it'll sink. Put it on the water right here, and it goes right down to the bottom. Now, how come it sank? Well, petrified wood isn't really all wood like this because every cell of wood has been replaced with minerals. So it's really kind of like a rock instead of wood, but you can still see the wood grain in a petrified wood. I've got another one right here. This looks like it might be the same ironwood, and it is, and it sinks. Got another piece right here. This is ironwood too, and it sinks. This is just wood that I got off of a branch of a tree, and it obviously floats. Now that's interesting. So we can't say that all wood floats because not all woods float. Some woods are too dense, and they're very, very heavy. Now, I've got a ping pong ball. Does the ping pong ball float, or do you think it'll sink? Put it on my water. It floats right at the top, doesn't it? It floats on top of the water. I've got another ping pong ball right here. Think this will float, or you think it'll sink? Put it in my water. Well, it goes all the way down right here, but it's coming back up. You know, there's a difference. Can you see the difference? This ball right here is floating at the surface. This ball right there is floating right below the surface. I wonder why. I wonder why. They're the same shape. They're the same size. But this ball right here, what I've done was I have taken the air out and I put some water in it. I put some water in it. And I can take in, let's see if I can find the hole. Where's my hole? Oh, here's the hole. I'm going to go ahead and squeeze some of the water out. See, the water is I'm trying to get that water out. So when I put the ping pong ball down into the water, then it floats just like the water does. That's interesting. So we can move both of these. Cool. So some things aren't quite what they seem. Those two ping pong balls, you know, you would think that they would both float, but nope. One went on the surface and one was below the surface. Let's check this out. I've got some cans of soda right here. Now this can right here, it has 12 fluid ounces. That's how much liquid there is inside of this can. And do you think it'll float or do you think it'll sink? Let's check it out. So I'm going to put it down like this, okay? And then we're going to let it go. And whoa, Now that one sunk to the bottom. It has 12 fluid ounces of soda in it, okay? And it was too heavy, and it wasn't buoyant, and it went down to the surface. Hey, I've got another can of soda, and this also has 12 fluid ounces. 12 fluid ounces. It has the same amount of liquid inside. You think it'll float, or you think it'll sink like that one? It weighs the same. Actually, it has the same amount, rather, of fluid in it. So I'm going to put this one right here like this and let it go. And, oh, is it sinking? No, it's not sinking. It's floating. Now, how come that can floats and the other can sunk to the bottom? Why? You know, there must be something different. Let's try to figure out, what is the difference? Let's check this out. Well, now there's some ingredients right here. Let's check this out. This one right here doesn't have sugar. It's got some kind of a sweetener, but it's not sugar. And this other can right here, let's reach in here without overflowing my tank. And this one right here actually has sugar. It has high fructose corn syrup. And that happens to be heavier than the artificial sweetener. So this is heavier because it has real sugar in it. And this can right here, it doesn't have real sugar. It's got a substitute sugar. So they don't weigh the same, but they sure do look alike, don't they? They have the same amount of liquid in them, but the one that has sugar happens to weigh more than this one right here that has an artificial sugar. You know, that reminds me, you know, can we judge somebody by the way that they look, or by the way that they talk, or the way that they might act? You know, we can't. We couldn't judge these two right here without knowing what's inside. And once we know what's inside, since this one here has sugar in it, we know that that one is going to have to sink. It's heavier than this one right here. This one has an artificial sweetener in it. So we shouldn't judge. Remember, they say you shouldn't judge a book by its cover. You got to get into the book. You got to start reading the book, and then you know whether or not that book is really a good book to read or not. Let's see if some other things might float. I've got a balloon. We can put some air in it. In fact, the balloon, I can tie this balloon off. Okay, there we go. Put it in my water. It floats very nicely, doesn't it? Yeah, it floats pretty well. Now, what will happen if I pop the balloon or I let all the air out of it? What will happen then? Will it float, or will it sink? Oh, I don't know. Let's see what we got. I'm going to go ahead and we're going to pop this balloon. Hold your air. Oh, geez. There we go. There's another piece of my balloon. I'm going to put that balloon in there. You know, that balloon, that rubber, it wants to float. So that rubber is made out of some material, okay, that will float. But if we put air in the balloon, then the balloon will float, that blue material will float on top of the water because of the air. So the air is very important to things that are floating. Interesting. I've got a candle. You think a candle will float, or you think a candle will sink? I'll put that in my water like this, and we'll drop it in there. Well, candles float. Well, that's interesting, because there's a lot of air. There's a lot of air inside of that as well. And the wax is pretty buoyant, and it will float. Now, we're going to do an interesting experiment with some other metal. First of all, I'm going to go ahead and I'm going to move this over, okay, a little bit here. And I've got some metal right here. Now this is foil, okay, this is aluminum foil. And I'm going to take a piece of this aluminum foil, all right, and rip it off, okay, there we go. Right, just like that. All right, here we go. Now, it's made out of aluminum, it's metal. Will it float? Well, let's see. What I'm going to do is I'm going to put it into a ball, okay? I'm going to make a ball out of this, okay? And you think this aluminum ball is going to float? or do you think it might sink? Well, let's see. I'm going to go ahead and put it on my water and see what happens. Well, it floats, but yet it's made out of metal. But why does it float? Well, let's see. Maybe because there's a lot of air trapped in it. You remember our volcanic rock? The volcanic rock, it floated, didn't it? Because it has what? It has a lot of air trapped inside of it. So let's see. Let's see if that is really true of our little aluminum block right here. So what I'm going to do is I'm going to try to squeeze some of the air right out of this aluminum block, okay, this aluminum ball. All right, so I'm going to squeeze it with my fingers, but I can't squeeze it tight enough. I can't squeeze it tight enough because it's just going to float. I'm trying to squeeze the air out, but I can't. It's sinking down there a little bit better than this. So what I'm going to do is I'm going to have a little helper. And so I'm going to take a hammer, and I have a piece of steel right here, and I'm going to try to squish the air right out of this piece of aluminum, okay, foil. Okay, I'm just going to try to squeeze the air out. I'm smashing those little air pockets right out of the aluminum, okay, out of that aluminum ball. And if I can get rid of most of those little air pockets, what do you think will happen? Think this little piece of aluminum will float then? Or you think it might sink? Well, we're going to give it a try. There we go. This is something, you can do all of these experiments at home. That's really fun. Okay, let's see now if this is going to float or it's going to sink. So I'm going to put that right here by my water. We'll drop it in here. Whoa! And it sinks like a rock. Sinks like a rock. In fact, it's sunk because we've taken a lot of those air pockets and just smashed them out. And there's hardly any air pockets in there. And so it's sunk. It's just like a solid block of aluminum, and a solid block of aluminum, well, it just doesn't float. I've got some interesting water to show you. Yeah, this water in here, it looks interesting. I have some other water in this beaker right here. What do you see? What do you see? See water? Yeah, I see water too. But there's something in there that you can't see that I know is there. I'm going to reach in there with my hand, okay? And let's see what I can come up with right here. Let's check this out, right? Let's see what I've got in my hand. What is that? Now, what are these? Now, these are what we call water marbles. A water marble. Now, a water marble is the shape of a marble. You know what they are. But inside of this happens to be water. And they start out like this. There's a little package of them right here. The little tiny, they're almost like plastic beads, okay? But they absorb water. And we call them water marbles, okay? Now, inside is a bunch of water. Now, I can take this and I can squeeze it. If I squeeze it, what do you think is going to happen? I think it's going to break. Let's see what happens. I'm just going to squeeze it in my hand, and sure enough, look at that. It breaks, but it's made out of water. It's 99% water. That's interesting, isn't it? Those little beads absorb water, and that's what we call they're hydrophilic. They like water. And as soon as they get to this size right here, they don't want any more water. They become hydrophobic. They don't want any more water. But that's very interesting. I can take that and I can put that in my big water tank right here. See if you can see it when I put it in here. See if you can see it. I'm going to put it in there. Can you see it? Or did it disappear out of sight? I have some more. I've got two more. I'm just going to plop them in. There's one. Can you see it as it goes down? There's another one. And as soon as I put them in the water, well, they become pretty much invisible because light goes through them about the same speed as light in this big tank of water. So we'll drop another one in here. We'll drop another one in there. So we say that they have the same light diffraction index as regular water, like in this tank right here. And I think I've got one more in here. I've got two more, okay? So I've got two more, and I can put that one in there, and I can put this one in there, but they seem to disappear. They seem to disappear in there, but they're still in there. Isn't that interesting? Wow, I can put my hand in there and see if I can find them. And I should be able to feel, oh, and they're at the bottom. They're at the bottom. Let's see what I got right here. Oh, there we go. I've got three of them, but I certainly couldn't see them, but I could feel them. I could feel them in the water. You know, that reminds me, you know, can you and I see God? You know, we really can't see God, can we? No. In fact, you know, Moses, he asked God if he could see him. And God says, yeah. He says, I'm going to put you in the cleft of a rock, and I'm going to pass by you and put my hand over you. I'm going to pass by you, and as soon as I pass by, I'm going to release my hand so that you can see part of me. That's interesting, isn't it? Wow. But you know, Adam and Eve, they saw God all the time when they were in the Garden of Eden, weren't they? But you know, you and I can't see God, but we know that God is real because we can see the evidences of his creation, and we can feel him in our heart, can't we? Yeah, we really can. And so we can tell by looking at the stars in the heavens and looking at all of creation, we know that there is a God, and God is real, and God can change our hearts. And if we give our hearts to him, he's happy to create in us a new heart and a clean heart. Well, let's take a look here. I've got a stick, and if I put the stick in the water, watch and see what happens. What do you see when I do that? I'm going to put the stick in the water like that. Now, what do you see? Does it look like the stick is bent? Does it look like it's bent? Well, the water is bending the light that we see in our eyes. The stick isn't bent at all. It's straight. But when I put that stick in the water, it appears that the stick is bent, but it's not bent at all. So that becomes an optical illusion. What we see isn't necessarily real or true. Hey, let's try something else. So I've got another container of water right here. In fact, I'm going to move our big tank over so we'll have some room, okay? And I've got a cylinder of water right here. Now, I can see through it, and you can probably see through it and see part of me. And I happen to have an arrow. Now, what direction is that arrow pointing? Well, the arrow's pointing to your right, isn't it? It's pointing to your right. But what happens if I put the arrow behind the cylinder of water? What happens to the arrow? Let's try to see if you can see that. I'm going to put this right behind here. Can you see that at all? Can you see that at all? Can you see that at all? So what direction is the arrow pointing now? Is it pointing to the right? Or is it pointing to the left? Pointing to the left, isn't it? So the water is diffracting, it's bending the light. That's interesting.